Hey, let's take a look at what we're going to be working with for a future tutorial here. This is obviously, it could function as either a pinball type game or a just some sort of marble game. And let me see if I can try to get one of these balls up the ramp to show you how that works. But while I'm doing that, I'll also explain that this is an object-oriented Actionscript 3 tutorial. So the fun thing here, well, I had one of them kind of go up the ramp. Let's see if I can. There we go, up and down again. The fun thing here is that you can just basically go and, for the most part, edit the board with just copying and pasting different things wherever you're on. You don't have to recode anything. I gotta put this back over here though. You can see that just by copying those guys, I got more flippers on the stage, and the same thing goes for the bumpers. And the balls, you can set those dynamically over this way. So if I just want to make this a little bit less crazy, I can set that down to 3, publish it again. And obviously, within the game, you could have some sort of slot or, just object that you collide with that would be some sort of multi-ball release button. And of course, you can do that at runtime as well. And another neat thing is you've got controls down here for how slowly you raise up the flippers, okay, and how quick you do it, obviously, which is optional too. Basically everything here is optional. The only thing that would take a little bit of setup are the ramps, and I'll show you really quickly how those work. This is kind of neat. I decided after playing with getting this initial ramp set up that probably the best thing to do is actually draw out your ramp and have the ball follow it along like a path. And this way you could do all sorts of like crazy swirly different types of ramps like that, and not have to worry so much about I don't know, recoding them every time or setting some sort of waypoint along the way. This actually does make it a lot simpler, and so I'll show you guys how to obviously set that up and make some really cool looking ramps. And of course you can change the scale at the same time. This ball slightly does scale up as it goes along the ramp here. And then you've got obviously other objects. These are some invisible ones. These are just invisible borders, okay, to kind of go along with that raised up ramp. And let's see, what else can we talk about here? Well, the more tilted, like something like this boundary here, the faster the ball will roll on it. So there's some decent physics going on here. And let me see if I should publish this one more time. Well, actually, I'll just let that kind of go. And I also have tested this out on my Samsung Galaxy Tab, and this does play through pretty darn good, considering it's chugging along at about 60 frames per second. And let's see if this, there we go. So you can see it rolls along there nicely. Every once in a while it'll chug just a little bit, but yeah, I think it plays pretty darn good. So that is what is ahead for this tutorial, and I think it's going to be a very good one, and maybe just the the basics of getting this pinball game out there, and then we can look at some more complex stuff later. Okay, let's get started here with pinball, and the first thing we should look at is the FLA file here. Of course, when you guys get a hold of all these files, there'll be a lot more in the library, and there'll be a lot of Actionscript files in here, but I'm just going to kind of get things started slowly and build them up as I go. And if you're not familiar with setting up class files and things like that, well, hey, this part is definitely for you, but I'll try to go as quick as possible because I know I got some advanced students too. So we've got our FLA file. I'll save out versions for CS3 and CS4. They'll all tap into the same Actionscript files though. So just open up whichever one is most appropriate for you. And already in here in the library, we've got a pinball symbol. If I were to just dump this out onto the stage, you can see it's already got the drop shadow set up inside of the symbol, and it's making use of this pinball art. It's just vector art. Reason I'm talking about this is because I'd rather you guys leave it sized up exactly as it is right here. Okay, so when I drag this guy out, it's good to go for all the code that I'm going to set up later on. It's not, I mean, you could mess with it a little bit, but you know what, just leave it like it is. And then otherwise, we are think about ready to go. So let's go and click on the properties for this pinball. You could also right click over here and go to properties, And what I want to do is set up a class file for this particular symbol. So the code that I set up inside of here is going to run basically whenever this symbol is on stage here. All right, so the class name I'm giving this is boundary object, and the implication I'm making there is that this could be any object that's going to collide with the boundary. And you might get this message right here. That's fine because we're going to create our own class file in just one moment. So just click on OK. And go over here to New, and we will begin with an Actionscript 3 class file. So click on OK. And it might give you this little prompt, class name, which we're just going to call boundary object. And you'll notice that is, of course, the same name that we just gave this over here. All right, so those are going to be linked up. Click OK, and it opened up in another window. There we go. We are going to immediately come in here and write extends movie clip. Okay, so this is going to have the same properties as a movie clip class. And of course, you want to save this file out, so just put it local to our other file. All right, so it's just right here with all that other stuff. And then we are going to write import. Actually, you know what? Let me just go ahead and copy in a couple lines here because I know we're going to use these. Import flash.display.movieclip and then events.event. Just gives us that functionality for those. To test things out, let's do this. Let's just send a little message to the output window that says trace. I am, well, all right, I am the pinball. Even though this is kind of more, I am a boundary object. But go back over here to pinball, and let's go to control, test movie, test. And sure enough, in the output window we get, I am the pinball. Okay. Now, I'm going to close this out, and then a nice little other panel you can go to is project, and then you can get this over here. And I've already set this up on my end, but if I were to refresh it, I would see that this boundaryObject.as file is already included in here. And this just makes it a little bit easier to test our project. So if I'm over here working with the code, instead of having to come back this way and then go to test movie, or even use a hotkey, I can just hit test project and it'll come up like it is. So if you want to do that, just follow the prompts in here. Just go to new project and just basically pick out that folder where everything is. And then you're also going to want to right click on the FLA here and just it'll give you an option that just says set as the default publish file or project file. Okay, that's ready to go. Okay, so let's make our little generic pinball or boundary object do something here. I'm going to set up a public variable. All right, that means another class could kind of look at this variable and find out what it is. If it was private, that would not be the case. It would be just private to this particular class. And this is going to be our y velocity. All right, it's going to be a number type, so not an integer. An integer would be 1, 2. A number could be 1.2. And I guess right now we'll just go ahead and also put in public var x velocity. And a lot of tutorials and a lot of coders will write, their variables like xv or underscore xv or yv. But at Cartoon Smart, I like to keep things kind of obvious, so we'll go with the full. Very long variable name, x velocity for that. And what we'll do is inside of this initial function right here, this is going to run automatically as we just saw a moment ago. I'm going to call another function, okay, and this is what I'm going to set up in just a moment. This function name is going to be called initial vars, and I am now going to write that function down this way. Private function and initial vars. Oops. Okay. And inside of here, I'm going to set up what the y velocity will be. Okay. And I guess I'll go ahead and also set up the x velocity too, even though we won't use it right now. This I'm going to make 0.5, so be sure that's kind of obvious. Actually, you know what? So it is a little bit more obvious. Let's write 0.5 there. And why did I set up a function to run right away? Okay, why didn't I just do this? Just throw those guys in there, forget about putting in another function. The reason is I'll also use this to kind of reset the pinball too if it ever goes off stage or something like that. So I could have called this function something like reset variables, but since we're kind of beginning here with the start of the lesson, I thought it'd be kind of weird if I put a function in that said reset variables. But so anyway, that's those are our initial variables for the velocity, and we'll throw a few more in there later on. But now let's skip down one line and write add event listener. It's going to be event dot enter frame. Okay, and I'm going to call this function that's going to run at the same frame rate. Enter frame handler. And this enter frame just means that this function is going to run once per second. Or I'm sorry, no, that would be very slow. It's going to run at the same frame rate. So for every frame, it's going to run this function. And what is your frame rate? Well, let's go over here to properties. Right now, it's set to 30. And come to think of it, I actually want this to be set to 60. We're going to kind of crank through this thing so it's really quick. And all right, so this function that I set up here will run 60 times within a second. So private, you know what? Well, all right. Private function enter frame handler. I'm going to just put in here that this is an event type. And now, with this pinball kind of rapidly running its own code, we can do something with this. Okay, so we could write this, right, which is going to refer to the object, whatever it is. Okay, in this case, it's the pinball. All right, and we'll put this dot y equals this dot y plus y velocity. Another way of writing this would be to just write plus equals, and then you can get rid of that part right there, and it's just kind of a smoother way of looking at it. So let's just give you guys both options, but one of them we will comment out, and let's see what happens if we go back over here to project and test the project. Hey, look at that. The pinball's falling down. Interesting, huh? Well, you might have noticed it went kind of slow, all right? It didn't accelerate over time, so let's change that. And, well, as everybody had a good look at this, I don't really feel like leaving it in there. We're going to do this version of adding something to something, like its own property throughout the lesson. You can do minus in front of here. You could do multiply. So just get used to seeing it like that. It just looks a lot prettier. Okay, we are also going to do the same little thing with the y velocity itself. Okay, so y velocity plus equals, and I'm going to add in 0.5 to this. Okay. And again, let's test the movie. Oh, it goes really quick, all right. That's fine. It's a little bit too speedy though. It is what we want though. It is adding to the y velocity over time. And you know what? It might be a good example just to trace out what this equals. Let's do it one more time. Okay, so well, it's just going to keep going even when it's off stage, right, like that. But you can see that. Started at 5.5, obviously, then went to 6, 6.5, and so on like that. And yeah, that just keeps going up. But keep in mind as well that maybe the real thing we should have been tracing is where that pinball location was at, because that keeps getting added those big numbers to it, so it's kind of making those exponential leaps downward. So it goes off the stage pretty darn quick. Now, what we could do to ease this up just a little bit is say if, and then y velocity is less than 10, then it's okay to just keep adding to it. Otherwise, if this were to be over 10, we're going to stop adding to it, and the ball will kind of slow down a little bit. And you might have noticed the frame rate chugged a bit there, and that's actually because I'm copying some files to another hard drive at the moment, so we're not getting the smoothest. Oh, there we go. It's pretty smooth. But if that wasn't happening, that's nothing to do with Flash. So, all right. And this is, I should kind of footnote things here that, this is kind of up to you too. I thought, just that the ball doesn't get too crazy fast as you're playing it and, hitting it with the flipper and things like that. I thought 10 was a good number there. It's up to you guys too. But I'll put a little note here. It says, just limit how quick or how high the line can get. Okay, now we're going to do kind of the same thing with the x velocity. So let's come down here. We'll write this dot x. Obviously, we're going to throw x in there as well. And we're going to change things up just slightly. We're going to multiply this by x direction. Okay. What is that guy? All right, well, we haven't set it up, so let's go and do that. Public var x direction. This is going to be an integer. And this will either be 1 or -1. Okay, so depending on whether or not it's either one of those, the x velocity will take us to the left or the right. Okay, so if we were adding, or if it was a positive number, all right, positive times whatever this number is, it's going to stay positive. And this will always be positive right here. It's going to go off to the right like this, okay? And if that were a -1, okay, then this is going to be negative, and this is going to go off this way. Probably the best way to explain this is to show it to you guys. But what I first want to do is write private constant. So this is going to be a constant variable. I'm going to make this all in caps here, which means that this isn't going to change, all right? It's always going to be constantly at -1, all right? And the same thing is going to be true for, hey, you guessed it, right. And this will be 1. So initially, what I will do then is say that x direction is going to equal, right, okay. And then let's give our x velocity a little bit of a, well, we can test it right now and just see what happens. Yeah, you can see that it goes off. Test it one more time. It veers off that direction. Obviously, the higher we make this number initially, the more you're going to see it kind of skew off like that way. Okay. But doing this is going to, I think, just be helpful for you guys. It was helpful for me, too. Instead of having to kind of worry about negative numbers or negative or positive numbers here and which direction they went, I just finally was like, wait a minute. Why don't I just make a variable that says right or left, okay, and work with it like that. Okay, so if I ever make the x direction right, you know which way it's going. And finally, let's do something similar for limiting the x velocity here. So the x velocity is if it's ever greater than 7. And again, I'm kind of throwing out numbers that I thought worked best. So these are the ones that you can mess with. If it ever gets greater than 7, let's just leave it at 7. Okay, so just equals that. Else, all right, otherwise, what I'm going to do is have the x velocity plus equal 0.005. Okay, and let me explain both of these when I comment through them here. All right, so this one's obvious. Just keeps the x velocity from getting too high. And then for this one, we're going to say that makes sure the x velocity doesn't ever be at 0, doesn't ever stay at 0. Okay, and why do that? That avoids the ball kind of like running into the same situation over and over and over again. Okay, and that is partially to blame too. I mean, if you set up your game board with maybe too many bumpers or whatever, it is possible for one ball to just kind of like do the same thing over and over again. Okay, we had that slight little change in there though, and over time, it might hit off the same bumper and then the same wall over and over again, but it will change. Okay, it will get out of that kind of little loop that it is in. But you know what? Hey, good news. I think we're actually done with our interframe handler here. And if we go back over to our pinball file, one neat thing you would notice is that you can just copy and paste all these guys, and they're all going to do the same thing. Obviously, they're all falling at the same rate and stuff like that. But that is the nice thing about reusable code here. Of course, there is, or class base code or object-oriented programming. There's no instance name for any of these guys. They just are these autonomous little guys that they know what to do. Okay. What we're going to do, though, is set up a class file for our main document. All right. And that is going to kind of act as a controller or almost like an analyzer for how these objects are going to work with each other, collide, things like that. And one example right away we'll do is if our pinball falls to the bottom of the stage, then it's going to start back over again. Okay, so let's go over here and write, this will be document main, okay, and as soon as we do that, it's going to say definition, all right, well, that means we need to go create one. Okay, so over here, new, and again, this will be an Actionscript 3 class file. We'll call this document main, and get this guy back in. There we go. This is actually also going to extend movie clip, and okay, yeah, save it out, of course. I'm also going to have you guys, if you're playing the home game, go ahead and just paste in, if you want, you can paste it in from the source files too. Just all the functionality we're going to need later on for this particular file, so we don't have to worry about it right now. And next up, what we will do is just make sure this is working. This is right high in there. Okay, so go back and read a project. You might need to refresh the, oops, here it is. Refresh, make sure you see that in there. Test project. And where's our output? There we go. Well, that is a problemo. We didn't get anything in the output window here. And I'm guessing I probably spelled something wrong. So let's go back over here to pinball properties, and yep, sure enough, document or dot, I just spelled that wrong. All right, so let's try this one more time. Flip back over to project, and hopefully, yep, sure enough, now I see high. And that's a good example of just not assuming that you got everything right away. Okay, so it's so easy to just put a trace statement in there and just verify that, what you thought is going on actually is going on. Okay, now that we know that that is running, let's do this. Go over here, and we're also going to set up an event listener for the interframe as well for our main document. Okay, so I'm just go ahead and paste that code in here. I'm going to change this though to be, I just like this name, main game loop. All right, and then too, if we're just going to be lazy and copy some code, let's go down this way. Just paste this in. Our main game loop, and put that down that way. And let's just put a note here. Oops, put a note right here. It says everything that we want to occur at the frame rate. And just to be kind of pretty here, what we could also then do is set up unique functions for each one of these things that it's going to occur in the main game loop. So one of them would be, let's say, test against boundaries. All right. And then, once again, actually, let's copy. No, let's not copy anything. Let's write private function. test against boundaries, and now let's put in our first one of those tests. And hopefully you can kind of see that if you did want to keep adding, stuff to our main game loop, it's just much easier to just kind of subdivide it into other functions. It's not going to hurt your code at all. It's just one way of organizing things. Okay, so here's where things get really fun. We're going to put a for loop in here. Okay, so I'm going to explain this out as I type it. So for, and then I'm going to create a variable inside of here called pinball, and that's just going to kind of help us remember what we're looking for here. Basically, I'm going to examine every child on the stage, and if it's a pinball, okay, we're going to do something based on that, okay. And this variable right here is actually just going to represent the child index of whoever we're kind of examining at that point. All right, and again, it'll be a little bit more clear later on. But we're going to start this off at 0, and then do a semicolon right here. We're going to say if pinball is less than, and for right now we can just do this dot num children. I'm also going to replace that with a variable later on. But for right now, we're just going to look at the stage and go, okay, how many children are on here? All right, and we've got the logo, the wood panel back here, and the actual pinball. Okay, so there's just 3 of them. So as long as pinball is less than 3, we're going to iterate through this loop. But let's keep going here. To close off our for loop, we need to write plus plus, so that'll just add 1 to pinball every time it iterates through here. Okay, so we could, you know what, if you're not really familiar with these for loops, let's just do this real fast. Let's put a trace statement in here. All right, and I'm just going to publish it real quick just so you can see what's going on here. All right, I'm going to close that out because it is just like looping over and over again. Starts up 0, 1, 2, 0, 1, 2, and over again like that. All right, because remember, we're running this function at the same frame rate, so then this gets run a lot of times, and so on like that. Anyway, now we're going to put an if statement inside of here, which says if get child at, all right, and this is a way of referencing the index of that child. All right, so if get child at pinball, sorry, is pinball, okay, and that refers to the class, and if I spelled it correctly, this would be a true statement. Happens to be is pinball, all right, so it's comparing, I'm sorry, well, for right now, it's actually a boundary object. You can maybe see where I'm going with that, but later on, it'll be pinball. But for right now, if get child at pinball is a boundary object, okay, then in that case, we're going to also check and see if, I'm going to write movie clip get child at pinball. I'm doing 2 parentheses here, okay? It might be a little bit easier to look at if I break them up a bit, all right? So we're going get child at pinball, and then we got to specify that we know that this is a movie clip. So we can write this next part, .y. And then we're going to say if that's ever greater than the stage, that's stage height, we know that you've gone off the stage. All right, so then let's put this down here. Okay, and it might be a little confusing to look at, but let's again put in here a trace statement. And we'll say, hey, I found a pinball. And then we'll put another one that just says, hey, this pinball went off stage. Okay, let's go. Publish it out, and let's take a look at what happened there. So at first, it just said, hey, I found a pinball, I found a pinball, I found a pinball, okay, because it's going through looking at the class, all right. And then finally it gets down here and it goes, oops, it's getting cut off. This pinball went off stage. Now remember, it's not doing anything when it goes off stage, it's just going to keep falling, okay, it's not going to disappear. I mean, it disappears out of our view, but it's still on there. So then it just keeps looping through and then through again like this. Now what we want to do is take this off. We don't need that, that's for sure. And we're going to take this same part right here, okay, and I'm going to call function or method, kind of terminology there, inside of this class. All right, and right now we have not written this function, okay, but that's what it's going to be the name. I'm going to say hit bottom, so just hit the bottom of the floor. And then we're going to jump over here to our boundary object, and we need to write this function. Okay, so come down here. It needs to be a public function because we're calling it from outside this class. And hit bottom, okay. And inside of here, if I can remind myself what we're doing, we are going to then write this dot y equals 0. Okay, so it's going to put that pinball back up at the top again. We can write this dot x equals math dot random, do 2 parentheses right there, and we're going to multiply this by stage dot stage width, and that is magically going to give us a random point across the stage width. So anywhere from 0 to, I think, 450 is the height of the stage. All right, and then we're going to call this function right here. All right, so we're just going to basically reset things, and it doesn't really matter too much now with not that much going on inside of here, but that's just how that is going to be for later on. So we'll go ahead and do it right now, and let's switch back over here. Let's test our project out, and oh, you know what did I do? Document main 37. So it's always good to explore these during the lesson. What did I put in here? Oh, I had that parentheses in the beginning. Okay, now we should be all right. And sure enough, it's kind of like it's raining pinballs, isn't it? By the way, if you do want to have a little bit of quick fun, comment this out and then write y velocity equals -10 and watch what happens when you publish it. It's going to get cut off, so I'm actually just going to open up the SWF file. That way I can make it a little bit smaller for viewing. Look at that. Ball just bounces right on off like that. Okay, so as you guys might have noticed, I was about to write is pinball over here. And before I take this lesson too much further, let me go ahead and subclass our boundary object so that we do actually have a pinball class. That way I don't have to go back and change it later on. And but kind of in the course of this, I don't want to get into much else to do with this because really we're just going to subclass this so we can make use of ramps, and that's kind of like maybe the more advanced thing to deal with later on. But let's just go ahead and do it anyway. It's a simple fix, or not fix, just a simple addition. Go over here, and this will be Actionscript 3 class. We're going to call this one Pinball. Okay. And we're just going to write extends boundary object. Now keep in mind our boundary object has all the properties of a movie clip. And with our pinball class extending the boundary object, it's also got all of those properties as well. So we can still call things like hit bottom on our pinball object. Okay, no problems there. Let me do this though. Let's go and no, actually we don't need to import in that stuff. So at this point, all we need to do is go back over here to our library and let's refresh this just to make sure I got it in there. Okay, library, and then we'll switch this out. So instead of boundary object, it says pinball. Okay, and then over here in document main, we'll check to make sure that this is now pinball, and hopefully I've got everything correct. Let's open up the Swift, and sure enough, it's raining pinballs again. Cool. And if you're just kind of getting used to object-oriented programming and things extending other things like that, one thing to kind of make clear is that this pinball can access the public. Ooh, actually, let's kind of get these in a better order. The public variables of our boundary object here. So if we wanted to change the y velocity But from inside of here, that is an option. And let's say you did something like public function change y, and we just write velocity equals -10. You could save that, jump back over here, and then change y. Comment that one out. And then again, you can see messes with that. Because I resized it kind of midway through there, it got a little funky, but it was doing the same thing as it did just a moment ago when we were playing around with that y velocity. So there's that to consider too, and we'll obviously come into more examples like this later on, but let's go ahead and get rid of this one and go through the tasks at hand. One thing we'll want to do later on is obviously have some sort of multi-ball mode, and to get that tested easily, let's just throw a bunch of balls onto the stage here, and let's start by getting rid of the one that we have on here initially. Okay, so now we've got no pinball, but we're going to come back over this way, and actually, sorry, outside of here, we're going to write a few variables. Private var, this will be number of balls to start. Yeah, kind of a long variable name, that's okay. We're going to set that to be 3, so we'll drop 3 balls on the stage. Again, this will be a private var. We're going to say balls on stage. Int equals 0. And then here's a new one for you. This type of variable is going to be, I'm just going to call it a pinball, and it's going to be our pinball class. Okay. Now, some of you might be more familiar with doing something like this, writing movie clip in there. But remember, our pinball is extended from our boundary object, and that's extended from a movie clip, so it's essentially very similar, but again, we're getting a variable of this type that's got all those cool little properties that we've set up. And now what we'll do is we'll come down inside of our initial function for when this document runs, and we're going to write var, oh, I'm sorry, actually, we're going to begin with a while loop, and this will be while balls on stage is less than the number of balls to start, then we will make a pinball. Okay, so there's our variable for that, equal to a new pinball. Okay, and then we'll write add child, a pinball, a pinball.x is going to equal math.random times stage.stage width, and then a pinball will just equal 0. And we want to make sure we don't set up an infinite loop right here, so we're going to write balls on stage plus plus. So as soon as this ends up equaling 2, okay, or I should say 3, then this won't run anymore, and there we go. So let's see what happens. Publish it out, and sure enough, we've got 3 balls on stage there. What we're going to do eventually is put add child at, and then throw in there 2. And you know what? I'm trying to think. Could we even do that now? No, I think actually 2 would be out of the index, because there's only 1, 2 symbols on there right there. So, and they start at 0. So let's see. Well, you know what? This isn't going to break things too bad if we test it out. Let's just put 2 in there, and I think, okay, right, that worked. If we'd put 3 in here initially, I believe, yeah, we would get this. The supplied index is out of bounds. So basically, what it's just saying is, all right, well, you're trying to put this new object 1 level higher than the most levels that are currently on there. Okay, so that's why 2 worked, and 3 did not, because 2 would be the next level up. What we want to do later on is have lots of other bumpers and flippers and things like that on there. So, at this point of development, 2 actually is the highest one. Later on, when we have all these other things on there, there'll be like 10 or 15 different objects. So 2 would actually be like, one of the lower levels visually. So all those other objects would be on top of the pinballs that we add to it. All right. And of course, as we add new objects onto the stage, then this index, the potential index or highest index gets higher. So the next pinball that we add is actually going to end up being visually lower than the other ones, which is fine. They're all just pinballs. It doesn't matter. And then, of course, we've seen this before, the random stage width. This is at 0, balls on stage. So now we do actually have a variable that we can track how many balls are on the stage if we need to use that later on. And otherwise, this might look a little bit strange to someone that... if you're thinking, well, wait a minute, how are we going to identify those particular pinballs? They all seem to have the same instance name, and that way of thinking, was kind of like how I would think about this too many months ago. But because I'm very used to programming, like you putting in here the instance name for the object and then referring directly to that with the code. Okay, with this object-oriented programming, it's in some sense kind of a lot looser, all right? And, we are looking at things like, is it of this type class versus is it specific instance name pinball 1 or pinball 2 or pinball 3? And you do kind of have some options like that. I mean, you could go through here and then write pinball.name equals pinball 0, okay? But then you've got a bunch of pinballs with the same name as pinball 0. So this could be, I believe you could put like a, int var or something like, a variable in there that, or actually, well, here we have one like so. But we're not going to do that. We don't need to, okay? Because, at least as far as things have gone in my project, everything is working just fine, just identifying it by the class, all right? But, I think it's just a good footnote if you are kind of used to doing things that other way. So anyway, we've got this set up. Let's publish it one more time. Again, we've got those nice 3 balls coming down. And again, each one is doing their own thing with their own functions inside of there when they hit the bottom of the stage. All right, I believe it's about time to get into some boundaries. And I've got over here in the library a movie clip called Boundary Rail. And let's set this up so it's its own class. Back over here to Actionscript, export for Actionscript. Just go class, boundary rail. Click on OK. Of course, we need to create that class file. And what's easier? Maybe just go into save as at this point. Boundary rail. Throw that in there. This will just extend movie clip, and then we do need to copy in that part. Oh, and of course, too, maybe it's not easier to go this way. We need to change that and that. Okay. Let's give this a quick test, though. Again, always want to make sure that what we assume to be true is true. I am a rail boundary. Let's go this way. And sure enough, okay, that guy's in there. And this will add a bit of fun to this because obviously if at least one of these balls falling down hits that rail, it'll kind of offset, when it comes back around, so they won't all be timed in the same. And let's go ahead and do that. Okay, so head back to your document main, and inside of our function for testing against boundaries, we're going to obviously be adding a lot more code. The tricky part here is that you do start to run into this problem where you have all these kind of trailing off brackets and everything like that. And it's just something that coders deal with, and I'm sure during a video it doesn't really help to have to watch that and be like, oh, I feel lost. Well, there's one thing that you can kind of do that'll help a little bit on your end as you're working through things. If you're on the Mac, you can hold down the Apple key and then the key on the keyboard that's got the quotation marks, okay? And wherever you are in your code, watch this, it'll start to highlight where the opening and closing brackets are, and if you just keep pressing it, it'll go up and so on like that. And I'm assuming, too, on the PC, there's a similar trick by probably holding that same key that's next to the space bar. If not, try the one after that and so on. And then, too, you can also, let's see, you can also bump things out like that as well, but not with that same key. It's the, with that one, it's the two bracket keys will. Again, if you're holding down that same modifier, it'll bump things out like that. But anyway, I found myself doing this a lot just to make sure I was actually where I was inserting in code where I thought I should have been. And speaking of that, we need to put some code in right after this. So let me just put a big old note in here. It says, now we will set up another for loop to check for boundaries. Okay, and so the way this is working is, again, we're going to go find a pinball, all right? We're going to make a note of that index. Okay, so we can always say get child at whatever that pinball index is. Then, inside of this, all right, we're going to go and find which ones are our boundaries, those index points, okay? So it's the same thing. We're just going to write another for loop inside of here. So it's a for inside of a for loop, okay? We're going to write get child at, and this time around I'm going to use, oh, I'm sorry, actually, I'm getting one ahead of myself here. We're going to write for, and then boundary, int equals 0. So while boundary is less than this dot num children, and of course we want to make sure that we eventually break out of our for loop. Oops. Okay. And maybe I should put a little note down here that says ends. All right. And you can probably imagine that there'll be a lot of things inside of here. Okay. First thing we'll do is write if get child boundary. And here comes the fun part, is boundary rail. Then we get to go and do another set of brackets. Okay. We could put our hit test code or our collision detection code as an AND statement inside of here and just put it off to the side. I'm kind of debating doing that for a couple reasons. It might just look a little bit better visually during the tutorial if I just start off another line of code here. But also, too, we might end up subclassing these boundary rails and then just having one larger generic class of like boundary. And in some ways I'm kind of reorganizing a little bit of this code as I teach it, So saying if you really want to learn something, teach it. And so, there's some revising going on, but I'll kind of keep going with the ways that, at least my finished example project are, and then maybe we can look at some ways of tightening things up a bit. But so we'll just proceed like this. So now if get child at boundary hit test point. Now we get to throw in our index point for the pinball, and again, we will write movie clip child. And let's just go ahead and copy this out. By now, some of you are probably wondering, why do we have to occasionally put in this movie clip and then put the get child at pinball in there? And it does vary depending on the property that you're putting after the index, after they get child at. And it doesn't really hurt to throw it in. Definitely it doesn't hurt, and for the most part, it's probably just a good idea to just throw it in there, and you'll avoid some errors later on if you go, wait, how come this isn't working? So I ended up, as I was going through the project, just putting it probably in more places than I needed to, and it more happens to come along with specific properties of just movie clips versus, I guess, more general display objects. But again, I'm just kind of throwing a safety in here and just using it. I might not need to with the X and the Y. At this point, I've kind of forgotten. It's been a long time since I made the original project. Okay, so let's see. I think now, if I don't have, no, I do need two parentheses back there. So that'll give us our hit test point, and if you aren't familiar with that, obviously we're just checking the boundary against a collision with the ball. We're looking at the center point of the ball, so this would be the X and the Y center. Actually, you know what? I'm sorry, I should correct that. I believe the center point of these balls is right there at the very bottom, okay? Which does make a pretty big difference. Otherwise, visually, it would look like the collision was occurring in the middle of the ball, whereas obviously, for something that's falling down like on a pinball table, as soon as it hits something at the bottom, it's where it collides. Okay, so now we've got our if statement, closing brackets, and we could now test to see if this is actually working. So we could say trace, hit, and let's give it a shot. Okay. Hit, and it just keeps on going down that way. So what we need to do at this point is put something into our boundary object class that will increment the ball upward and also make it bounce upward. And I'm going to divide these into two different functions because at different times we'll need both of them. So anywhere inside of here is good. Let's just go ahead and we'll keep putting them down here at the very bottom. We're going to write public function. And of course, this is public because our document main class is going to access it or call it, or send a message to it, whatever terminology you want to use. Okay, so this function will be called increment upward, and this is pretty easy. It's just going to do this one thing. This dot y plus equals -1, and you know what I kind of feel like doing? Let's set up a private constant for this, and we'll do 2 here. Can you imagine? Up and down. So this one will be 1. Up will be -1. So if we're going to send that ball back upward, it's going to be going negative, or we're going to be adding negative values to it. So that's why that's a -1. And then, yeah, that should be good to go. So let's just write up in here. And then that's actually done. And you know what? Before I confuse you guys too much, let's go ahead and use this one, and then I'll set up the next one where we bounce upwards. So go back over this way, and we are going to put in here a while loop. Yes, adding more brackets inside of here. This time, though, you get kind of a free pass. You can just copy this thing, that whole statement right up there. So just write while. Come down this way. And we can just write movie clip. Good child. Another thing here that I could just copy through. I should just always have this copied into the clipboard. Oh no, you know what? We're actually using this one too. Okay, movie get child at pinball dot increment upward, and that should be ready to go. Let's see what happens. Oop, I messed something up. Well, that said, my error was at Oh, well, yep, line 15. That would be the error, all right? I took off the wrong thing. Okay, let's give this another test. And hey, look at that. They just stop there, and let's wait for another one to come on down. There we go. And as soon as they're off, there they are. One cool thing that I didn't really mention here was that this true statement is actually testing against the vector art inside of there instead of just the bounding box, which is obviously going to be pretty important because with these shapes. Right now, this bounding box is the blue outline around that you see when it's selected is pretty tightly wound around the actual shape itself. But when you get things like, let's just put any other shape inside of here, now your bounding box is kind of a little different, huh? And I mean, just to actually prove this point, we could publish this again, and hopefully, sure enough, see how that worked. Oh, pretty slick, eh? So. That will be quite useful when we do things like rotate this guy, which I forgot what that's going to look like. Yeah, okay. So even right now, it's looking pretty good, but we'll smooth that out some. And let's, we'll do that by putting in another line right after our while statement, which is going to be to bounce the ball upwards. So let's go back over to our boundary object. Jump right back down here. We can just copy and paste this in. Let's call this bounce up. And this function will be y velocity equals -1. So we're going to multiply it by -1. And then we're going to make the y velocity less than what it currently is. So to do that, we'll also multiply it by 0.6. And let's come back over this way. We can just copy this part. Paste that in. Bounce up. Let's see what happens. Doink. That was my phone, by the way. Sorry. Forgot to mute it again. So you can see that it's, eventually it's going to stop bouncing, and because, we keep multiplying the velocity, lower and lower, and then it's just going to seem like it's rolling. Next up, let's write a function called go left. And let's also put in, you guessed it, a function called go right, and we'll call these two, whether or not we want the ball to go left or right when it collides with our little boundary there. And we already had this set up kind of nicely from before. We just need to write x direction is going to equal left, correct? Because remember, this is just -1 that gets added in or multiplied in to the x velocity. So as soon as we make that little change, it's gonna come right back around and affect which way the ball is going. Of course, the same thing down there. And now, by what crazy bit of magic do we make it so that this ball will roll left or right? Well, check this out. We're going to put in here if, and you know what, let me just go ahead and what I want to do is I want to kind of stick with one or the other. Either I use that movie clip in front of you or I don't. Boundary. All right, so if get child at boundary dot rotation is less than 0, okay, then we're going to do one thing else. We're going to do something else. And maybe I should put a little note here. And rotation. Throw that in there, and this is going to be the one that goes right. Okay. And obviously, you've figured this out. This is going to be the one that goes left. And now let's go and rotate it. Okay. Keep in mind, too, that when I just drop this guy out onto the stage here, its rotation is at 0, so going one way or the other with it is going to trigger one of those two options there. All right, so, and I guess obviously we could throw in an equal sign here too that says, if it's equal to 0 or if it's greater than. Okay. And let's wait for a ball to drop. Oh, look at that. Amazing. So now it just knows, based on that, which way to go. Does anybody want to try it the other way? Well, let's do this. Let's set up a few of them. Doink. Hey, pretty cool, huh? That in itself could be some sort of game, couldn't it? I don't know, just a marble roll game. Kids would dig it. I would have dug that. That's what I did with blocks as a kid. So anyway, we don't have to watch that over and over again. But I think things are working pretty well, huh? Well, before I leave you guys here at the near end of part 1, I do want to show you that you could switch this from an int to a number and then make it a decimal value. And I don't think that's going to give you much of a performance hit, because remember where this takes effect is in this increment upward statement. Okay, so during that while loop right there, it calls this, and oops, what did I just commented that out? It calls that, which of course comes down here, and that's that value right there. So, obviously the quicker that this is no longer a true statement, where they're no longer colliding, the quicker it gets through that while loop. All right, but so the smaller the number, obviously the more times it's got to iterate through that. I think you will notice, though, if you do make that a smaller number, you get a bit of a smoother roll down, okay? So just try to keep your eye on one of these balls that, it's like rolling down like that. You get less wobble in there. So probably what I'll do is I'll leave that at 0.5 right there. And before I totally am out of here, I'll leave you guys with a little bit of a puzzle. Check this out. If I were to copy out one of these guys and trap our balls down there, you'll see a bit of a problem. They kind of spaz out like this, and they even increase their kind of X velocity and start going pretty nuts. So that's one of the things we'll end up fixing at the beginning of part 2. But until then, I hope you enjoyed just dropping things down here and creating all sorts of weird scenarios for, I don't know, whatever this is. Okay, I'll see you back here, hopefully.